Alright, this is Matgen110. We're looking at Chapter 9. We're finishing off the note packet with this video. It's 9.4 and a 2. So they want us to graph y equals x squared. So let's put in some 0, -1, +1, 2, -2. And take a look at what we get. So when I input 0, we get 0 squared, that's just 0 output. When I input -1, that is -1 times -1 is +1. When I input +1, that is 1 times 1, which is +1. Pop in a 2. 2 squared is 4. I pop in a -2. -2 times -2 is also +4. So we're getting repeat values for y, and that's okay. So let's graph this. 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. And what we get is this curve. You got to make sure not to make it a straight line. It's a curve, and it's called a parabola. And that parabola is getting wider forever. I know it looks like it goes like a vertical line, but it never actually goes vertical. It keeps getting wider and wider and wider and wider and wider and wider forever. All right. So if you have y equals a positive number in front of the x squared, it opens up. If you have y equals a negative number in front of the x squared, it opens down. But they're parabolas either way. That just opens up, it opens down. Because a is positive. And if a is negative, oops. Yeah, a is greater than 0 or a is less than 0. A is, remember, it's ax squared, so y is equal to ax squared plus bx plus c when we did quadratic formula. So the thing in front, a lot of times we refer to as a. So look, this one they just want to know, does it open up? Does it open down? Well, that one opens down. That one opens up because of +3. That one opens up because of +1. All right. And then for 4, 5, and 6, they want me to find the vertex. The vertex is either the lowest point on the parabola or the highest point on the parabola, whether it's opening up or opening down. So a lot of times they'll talk about the vertex of a parabola as maximums or minimums. Those are very important in a lot of different physics problems. We're always worried about finding the vertex. All right. So here we've got 2x squared plus 6x minus 3. We've got 3x squared minus 7, and we'll do another one. 6y equals 2x squared minus 8x plus 1. They want us to find the vertex without graphing it, just find the vertex. So above they give you this formula. X is equal to the opposite of b over 2a. And if you remember your quadratic formula, that's the very first thing. Then there was a plus or minus square root added to it. But if you just do the opposite of b over 2a, that'll give you the x coordinate of the vertex. So let's do it. Where a is 2, b 6, and c is -3. And so we're going to do the opposite of 6 over 2 times 2. So this one is -6/4. That's -3/2. That's, let's call it -1.5. All right, that's the x part of the vertex. To find the y part, you sub that in. Everywhere where you see an x, we put a -1.5, and we work that out, so that ends up to be 4.5 minus 9 minus 3, -7.5. And so our vertex is the point -1.5, comma, -7.5. All right, let's do another one. A is 3, B is 0 because there's no x term, and C is -7. And so we do the vertex is the opposite of B over 2A. So in this case, the vertex is 0 over 6, which is 0. And then if we pop 0 back in, y is -7. So 0, -7 is our vertex for that second one. And for the third one, A is 2, B is -8, C is 1. Oh, I keep finding C. I guess we don't even need C. It's the opposite of B over 2A. So the opposite of B over 2A is 8 over 4, which is 2. And then if I take 2 and put it in everywhere where there's an x, we get 4 minus 16 plus 1. And so -13. Uh-oh, wait a second. Did I go too hasty? 2. I got 2 in there. Oh, 2 squared. That's where I made my mistake. 2 squared is 4 times 2 is 8. That should be 8. Ah, I missed the squared. So that's -8 plus 1 is -7. There we go. So we got 2 comma -7 for our vertex on that one. All right. Then they have some matching problems here. We'll go super fast. So if you just know something about the picture, so look, we've got y equals x squared minus 5. We got y equals x plus 4 squared minus 3. And we've got y equals x squared minus 1. So look, if I have x squared, y equals x squared, that's the general graph. Minus 5 is going to slide it down 5 units. Minus 1 is going to slide it down 1 unit. So this is a parabola that opens up. That's down 5. So this one is actually goes with B. That's y equals x squared is like the parent graph, and this minus 5 takes it down 5. The minus 1 takes it down 1. So that one was A. Well, and then by default, this one has to be C, right? Because we got A and B already, so we know that's C. But this is actually called vertex form. You think about what would make this be 0, that would be -4. And then when it is 0 and it's all gone, y is left to be -3. So that's the vertex. So when we were completing the square, we had this equal to a number. If we would have moved that number over and replaced it with a y, we would have had it in vertex form when you were doing the completing the square process. -4, -3 is down there, and there's our parabola. All right. Okay, they said do everything to this. Number 10, y equals x squared plus x minus 6. First, does it open up or open down? Well, it's positive x squared, so it opens up. Next, it says find the vertex. So we'll do the opposite of b over 2a. So we got a is equal to 1, b is equal to 1. The opposite of b over 2a is -1/2. I pop -1/2 back in, -0.5, 0.5, and then -6. And that gives me 0.25 minus 0.5 minus 6. And that is -6.25. So we got our vertex is weird. -0.5, we'll call it -0.5. -0.5, comma, -6.25. All right, C, it says find the X-intercepts. Well, that means y is equal to 0. So look, if I have x squared plus x minus 6 equals 0, because the x-intercepts were across the x-axis, I can use my sweet factoring skills. Multiplies to be negative 6, adds up to be 1, that's negative 2 and 3, and then the opposite, right? Equals 0, so I add 2, equals 0, so subtract 3. So those are my x-intercepts. D said find the y-intercept. That's pretty easy to find. The y-intercept is just you set x equal to 0. So look, we put in zeros everywhere where there's an x. Y is equal to negative 6. So 0, negative 6. And then sketch the parabola. So now look at all of this information we have on the parabola. We know it crosses the y-axis at negative 6. We know it crosses the x-axis at 2 and negative 3. And that's really enough, just about enough, but it's got a weird vertex. So the vertex is negative 1/2, negative 6.5. So that's a weird spot. That's like right here. Really close to that one. And there's our sketch. All right. And then the last one, it says the discriminant A sub 2, we're looking at A2 now. The discriminant is the thing inside the square root in quadratic formula. So look, here's quadratic formula, the opposite of b plus or minus the square root. B squared minus 4ac all over 2a. And this thing right there is the discriminant. So it says the discriminant is b squared minus 4ac. That's the discriminant. So in a parabola, if the discriminant is positive, then think about it. If I look at that, that's the square root of a positive number. I'll have a parabola that hits the x-axis in 2 spots. If it's b squared minus 4ac, the discriminant is 0. That's a special case. That means the vertex lands exactly on the x-axis. And if I have a b squared minus 4ac is negative, well then I'm taking the square root of a negative number, which drives me into the complex number system. And that won't cross the x-axis in any real part. Those are called complex or imaginary numbers. So this is 2 solutions, real solutions, 2 real solutions. This is 1 real solution, 1 distinct. That's called multiplicity when that happens. It counts as 2. And this is no real solutions, but it actually has 2 complex or imaginary solutions. All right. And that's it for all of the notes for this semester. Thank you so much for being patient and letting me do lectures over videos.